Okay, so we're going to start with gates now. Start with the most basic gate, the inverter. There we go. The symbol for the inverter is that. This is your input, and this is the output. General term and convention. If an input is inverted, I'm sorry, if an output is inverted, there's a little bubble by the symbol. So there is a symbol like this. This is a buffer. These are not the same. In the lab, you will not be using buffers. You'll only be using inverters. So the buffer you can ignore for right now. The truth table for the inverter is if the input is low, the output is high. If the input is high, the output is low. Like I said, this is the most simple gate there is. You will not be tested on this, but if you're interested, the gate is constructed on its most basic level, or can be constructed in this way. This is a transistor. This is a resistor. When the input here is low, if this is low, this is power, and this is ground. If the input is low, this transistor is turned off. So the power goes out that direction. Whereas if the input is high, power goes this direction. This creates a short circuit here between the resistor and ground, which in turn pulls the output low. It pulls it toward ground. There's a more direct connection between ground, no resistance here, to ground, as opposed to high resistance to power. So it would be more inclined to be ground or a low signal. Yeah, and notice I'm using the terms high and low voltage. It is not on and off. Say this is a battery. like a large D cell battery. You have the plus terminal, you have the minus terminal. High, being high is on the plus side, being connected to the plus side of the battery. Low is being connected to the low side, the minus side of the battery. Off is connected to neither. Off is a high impedance state. Also called high Z. Also called the tri-stated. And that does have use in some systems, in some parts of the system, when a line is going to be shared by multiple devices. The devices that are not being used are tri-stated, so they don't influence the wire, whereas the active device will have either high or low. So when you that's my spiel about off. You do not answer off. It's either high or low. For this class, we don't get into the tri-stated state or high impedance state in this class. I believe you might in computer organization. I'm not sure though. Inverters can be linked together. What would the truth table for that be? Input and output would be the same. A double negative situation makes a positive. So this would be A, low, high, out, low, high. So you can feed an output of one gate into the input of a second gate. You cannot, however, have that. That's a bad thing. You don't link outputs together, because in this situation, if B is low and A is high, what will happen? A short circuit. Exactly. You'll have a high signal here going to a low signal here, and things will start smoking, and we all know smoking is bad for you. In the lab especially. Things blow up, catch fire, that sort of thing. Blow up only if it's really high voltage. But yeah, that's a bad thing. Do not do that. Do not combine outputs. Now you can have you can have a situation like this. This would act like a buffer, like I did before. The outputs would follow the input, but the power available would be higher because you have two gates driving the current for this. So if you would need to go to multiple gates from one output, you do a circuit like this, and it will generate enough power to drive the inputs of multiple gates. But this is okay. You can link inputs together. They'll just have the same value. So if this is low, this will be high, this will be high, this will be high, this will be low, this will be low. Okay? So that is the how it's represented. In a logical expression, out equals a bar. A bar over the input indicates that it is inverted. If you're typing something up, like a lab report or something like that, something that's also acceptable is A prime. That you could do on a standard typewriter, or standard typewriter keyboard, standard keyboard. So, and also, what you'll also see is in some data sheets, to save typing, out being represented by a Q, not an O, because that could be confused with a 0 in binary. So they use Q to represent the output on some data sheets and other documentation. So that's how you would express it in a logical expression. As we learn the other gates, we'll get into more complicated expressions and how to link them all together. But any questions about the inverter? Okay, fairly simple. Most easily implemented with one transistor and one transistor and one resistor. Actual implementations of that are use 2 transistors actually. One to control the output for the high state, and one control the output for the low state. But that's a little bit more complicated. It gets into semiconductor design and beyond the scope of just about every undergraduate class that I'm aware of. But Most simply, one transistor, one resistor, easy peasy. Oh, part number. The part number for it is going to be I believe 7404. The X's in there represent letters that are used to describe the technology used in the chip. So older technology might be a 74 LS04. Newer technology, I believe, is the more stable and clean is 74 ACT04. Functionally, they're the same. They have the same pin arrangement on the chip, all that sort of thing. So no big deal there. As far as the chip is concerned, they should go over this in the lab class, but I'll go ahead and describe it for you. And this is in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13, and 14. So these inverters are in what's called a 14-pin DIP package. DIP stands for dual inline package. There's going to be a notch on one end of the chip. Orient that to the left, and your bottom left corner is the pin 1, pin 2, pin 3, counts around. It doesn't go 1 through 7 and then 8 through 14. It goes 1 through 7, 8 through 14. Power and ground are 14 and 7 respectively. Without the power and ground connected, the chips will not work. So that is the $74.04 DIP package. You also see them called C-dips for ceramic dual inline package, or P-dips, plastic dips. But all means the same. All the same type of chip. But that should just about wrap it up for today. Have a nice long weekend. See you Wednesday. We will be covering the AND logic gate. Yeah. So have a good day.